Welcome back, everyone. So I hope my audio is audible. So today I will go with the refraction on plane surface. So under this refraction on plane surface, so I hope my audio is audible. In this only, first glass lab applications I will explain, and TIR will discuss. The prism is refraction on inclined surface we can discuss, and curved surface already I made one video. So again I will discuss some points about the curved surface. So coming into refraction is the phenomena when light traveling from one medium to another medium, it takes the bending at interference. It takes deviation at the interference of two media separating. That is because of the change in light velocity from one medium to another medium and depends on the nature of the medium. So here the speed of the light is more than that media is called rare medium. Speed of the light in any media is less. That media is called denser medium. So this the rare media and denser media based on the velocity of light is divided, and based on refractive index also you can divide. So refractive index is the property of optical density, the media's optical density. Optical density and mass density are different. Optical density means refractive index. So this is ratio of the velocities. N is equal to C by V, the ratio of velocity of light in the vacuum with respect to media. Whereas mass density is equal to mass by volume. Mass optical density more means that is called denser medium. In some of the cases, its mass density also more, but not always. So kerosene has less mass density, but optically denser it is, so denser medium than water medium. Compared to water medium, kerosene have more mass density. Mass per unit area means kerosene's water density is equal to density of water is equal to 1000 kg meter by kg by metric. So whereas density of kerosene is equal to 800 kg by metric. This is mass density, mass per unit value. So where the optical density of the kerosene is more than water. Means for light, the kerosene act like denser medium than water medium. And when it is light traveling or refracting from one medium to another medium, so properties, the velocity, wavelength of the light or color changes, but frequency does not change. Frequency does not change. Frequency means wave number or the number of vibrations by the light in the media. So frequency does not changes. Depends on wavelength and lambda. This velocity of the light velocity and light wavelength, medium to medium will differ. So that medium is denser, so velocity is less. Automatically wavelength also less. So velocity is more, that medium is rarer medium. And in the denser medium, light bends towards normal. That means traveling from rarer medium to denser medium bends towards normal. The light traveling from the rarer denser to rarer away from the normal. So this is denser medium here. Denser to rarer medium. By the angle of given refraction, we can tell the media is denser or rarer. Refracting angle is less when that media that is denser. Refracting angle is more than incident angle that is rare. Finally, the refraction means when traveling from one media to another media, the light deviates its path towards normal or away from the normal, depends on the from which medium to which medium it is traveling. The rarer to denser or denser to rarer. Similarly, the refractive indexes are two types. One is absolute refractive index and relative refractive index. So absolute refractive index means the ratio of the light velocity in the medium to vacuum. And this value is always more than 1 because C value is more. The relative refractive index is the refractive index of medium one media with respect to another media. So here the N12 are like this, N12. That means refractive index of 1 with respect to 2. N1 by N2. N21 means refractive index of 2 with respect to 1, N2 by N1. According to many authors and books, N2 is always refractive index of denser medium. In all the authors they are taking like that. And somebody will go with refractive index as letter mu. But for me convenience I am taking a letter N. Okay, that is our use. So N2 is always refractive index of media, refractive index of denser media. And actually the refraction phenomena, reflection phenomena and recliner phenomena are the phenomena explained by Newton corpuscle theory. That means light considered as a particle. So the refraction is a phenomena, attraction phenomena of particles. The light attracted by the particles of medium. The whereas the reflection is a repulsion phenomenon. So after that, after Newton corpuscle theory, those points and all after suggested and the given run by producing the giving the ideas of Huygens wave theory, Maxwell quantum theory, and de Broglie wave theory. So after that, the wave nature came to explain the remaining properties of light: dispersion, scattering, interference, photoelectric effect, and all. With that wave theory and wave explanation, we can explain this reflection refraction also. These phenomena also are satisfied. And light have dual nature, means depends on the surface on which size it is incident. So it is considered as a wave or like ray. Right. So coming into laws of refraction, Snell's law. So Snell's law said that So according to Shen's law is not equal to sin A by sin A. So in some of the books they will write Shen's law is equal to sin A by sin A. So this is only valid only for a light ray is traveling from rarer to denser medium. So whenever you want to apply the Shen's law for solving the problems, so this is very very important formula and point what I am going to tell now. The refraction on plane surface and curved surface, whatever the problem, only the one formula had to apply Shen's law. So that is why I'm trying to give how to apply the Shen's law for in all the cases. So according to Shen's law, refractive index into sine of the sine of the angle in that medium, either incident or refracted. Means n into refractive index into sine of incident or refraction is equal to for example, here in n1 media incident angle is there, means in n2 media automatically refracting angle will be there. So that is equal to the product of n into sine of the angle of incident or angle of refraction is constant. So example here I try to explain. See, the rarer and denser. The light ray is traveling from denser to rarer. So it is given like this. Nd into sin r equal to n1 sin r. So here Nd means denser medium refractive index, N2 by N1 equals sin r by sin. So whereas rarer to denser, N2 by N1 equals sin a by sin r. This is Snell's law. Snell's law is given for this application, rarer to denser. So this is the general phenomenon, the general explanation of refraction by Snell's. So that means whenever you are applying, so from the given condition, for example, like this problem is there. So here this is media, glass media, water media, and air media, other side. So light is grazing coming from this water media and coming from glass media. Means initially it is starting here. So normally consider here. So water and glass, water is rare medium with respect to glass. So it is coming like this. Means arrow marks are given like this, means the refraction starting from glass media, means incident starting from glass media, refracted in water media, and again like this. So your refractive index of glass media is equal to 1 by sin A. So if you take sin A by sin R, the Shen's law, so it make you confused. So this rule we follow, Ng, refractive index of glass media into sin of incident is equal to n water into sin of refracting angle. So this is equation 1. And again here, sin of, here also this angle R means here also angle R. Therefore, NW into sin R is equal to 1 into 1. Therefore, Ng is equal to 1 by sin. So this is application of Snell's law for given any surfaces. If there are 3 or more surfaces, means the same method will follow. N into sine of incident, sine of angle in that media, that is incident or refraction. So that is out of matter. So coming into, so this is about the introduction about refraction, the nature of the media, refractive index, absolute refractive index, and the relative refractive index. And here I forgot to tell about the refractive index. The refractive index is inversely proportional to velocity. So refractive index is inversely proportional to velocity, and n1 by n2 is equal to v2 by v1. Inversely proportional. So that equal to frequency constant, therefore lambda 2 by lambda 1. So this is under refractive index. And the second law of refraction, that means incident ray, refracted ray, and normal at the point of interference drawn lie in the same plane. So the vector law of Snell's law we can write like this: n1 into I cap cross n cap. That means in n1 media incident ray is there, and these are the unit vector of incident and perpendicular vector is equal to the refractor ray unit vector along the refractor ray, the unit vector along the refractor ray, and normal cross product of normal into n2. This is vector form. Means, for example, they have given one example is there. I will try to explain. 6i cap plus 8j cap plus 10k cap is given, suppose. So now here the incident ray is there in xy plane. So then z xy plane means z plane or z axis will be the normal. So now we have to z component is along normal unit vectors you have to find out for incident unit vector. That means the given vector by magnitude of that vector is unit vector. The normal vector by magnitude of normal vector, that is vector cross product, will give the r cap into n cap. So this is calculation of vector form of vector application of Snell's law. So now refraction and glass law we'll see. So refraction and glass law applications are apparent depth to real depth. Real depth means this is consideration. We will consider where the object is lies or thickness of the glass slab. So the refraction phenomena through glass slab gives the concept of vertical shift, lateral shift, and on plane surfaces TIR and optical fiber. TIR application is optical fiber. In the glass slab, vertical shift and lateral shift concept will study. So here you can see the ABCD one rectangular glass slab is taken. And it is the incident ray is given here from one media to glass, glass to another media emerging. So angle I is incident angle, angle R is refracting angle, and I minus R is deviation angle. Angle E is emergent angle, and X is equal to lateral shift. And here the vertical shift. These 2 points is called vertical shift. B and E. B is vertical shift, and here some A dash and E is apparent depth. So A E dash is apparent depth, A dash E, and BE are vertical shift, BC is lateral shift, and AB is refractor ray, and angle A means BAD is angle of refraction, and I minus R is deviation angle, angle E is emergent angle. Lateral shift means the perpendicular distance between incident ray and emergent ray. And here, so maximum there is no refraction condition. So for example, the light incident on the glass slab perpendicularly. So the light incident like this, perpendicular direction, no refraction takes place because no deviation. According to definition of refraction, at the interference there will be deviation, then it will said to be refracted. Right, light is refracted. Otherwise, this is one condition. Otherwise, the medias are same. Physical properties of mediums are different, and chemical properties also different, but they can have same refractive index. In that case, the light will travel in same path, along the same path. Here also y will tell me same media, so no deviation, it will go in straight line, so no refraction taken place. These are the no refraction conditions.